All right, hello, EM aficionados. So I've been meaning to do this video for a while here. So this is going to be the companion video to the video I did on the STEM about, help, I can't find the beam. Okay. So I wanted to do one for the dual FIB SEM because you can also have, a similar set of issues on the dual FIB SEM as well. Okay. So we're going to talk about this today and, how to check if you are having issues. Okay. So as I have to do here because of the screen capture thing, I just need to change this view. That's going to make it a little easier to see the quads here, although makes it a little harder to see what's here with the text. All right, let me put this back and okay. And if we need to swap it out, we will, because it's a little easier to see this. Okay, so let's start by first thing we got to make sure is everything's cool with our vacuum system. Okay, so down here you can see our little instrument diagram, right? And so we see everything is green, okay? So the chamber vacuum, the electron column vacuum, the PFIB column vacuum. So if you mouse over it, you're checking, you can see the different vacuum readings, okay? So as long as these are all green, then you shouldn't have an issue there, okay? But that's the first thing because we can't turn the beams on if we don't have the proper vacuum state, okay? So that's the first thing. The next thing is we want to make sure that both of our sources are on, okay? So if we click on the SEM quad, we can look over here and we see that under beam on, we have a green bar. And then I believe if we mouse over it, okay, so it's giving us an emission current, okay? And I believe you can also, yeah, you can see it down here as well, okay? So if this is green, you're reading an emission current, then you should have electrons being emitted from your FEG tip, okay? So we should be okay in that regard. If we do the same thing for the PFIB, right? So again, we want to make sure this is green underneath. And again, if you mouse over it, it's giving us an emission, okay, in milliamps, which is this is normal for PFIB. With the gallium system, normally you're dealing with like a couple microamps, okay, so order of magnitude or a few orders of magnitude different, okay. But again, right, as long as this is green, that means we have xenon ions, going through our PFIB column, okay? So we should be good there. We don't have the beams on right now, so that is why down here we are reading nothing for ion beam current and nothing for specimen current. Now I wonder, okay, so if you right click on this, you can specify what goes in these. So we already have pressure and the different currents. So yeah, there isn't one for the what's it called? There isn't one for the electron beam current. That's what the specimen current is actually, or I can show you how it's that. Okay. Okay. So let's go ahead and let's hit the wake up button. Now, I mean, well, before I do that, so one other thing I need to mention here. So depending on the source of your dual beam, if you have gallium source or you have a PFIB source, so the gallium source has to be, woken up, because when it's on, whether or not you have the beam, when it's awake, whether or not you have the beam on, it's being depleted. With the PFIB, it's not like that. Okay, so with the PFIB, as long as we don't have beam on, we're not actually depleting the xenon source. Okay, that's a fundamental difference between those. So this can be just left on like this, and you're not actually depleting the PFIB source. With a gallium source, you are. Okay, as long as this bar is green and you've got emission, you're depleting the source whether you have the beam on and you're doing anything with it at all. Okay, so anyways, let's go ahead and hit the wake up button. Okay, so all that does on this system is it actually just turns on the beam. So actually what that looks like is it's actually opening up the isolation valves. So now I wonder if there's a way to pull up the vacuum diagram. If we click on the specimen exchange window, okay, so if you click on this and you click vacuum, so we can actually see the vacuum diagram here, okay? So right here, this is the SEM column, okay? So these are the isolation valves. There's one after the gun and there's one after the mid column, okay? So these are both green, meaning they're open, right? So we've got electrons going all the way through. And with the FIB column, it's the same thing, okay? Except there's one isolation valve. So actually I can show you this here. If I click sleep, it should close these. No? Interesting. Okay, there we go. Okay. So yes, you can see that it actually, oops, sorry, let me turn this back up. Yeah, so you can see that the gun isolation valve is still open, but the lower valve here for the SEM is closed, and the valve for the PFIB is closed. Okay, so that's another thing you can check. Let me go ahead and hit wake up. So you can check and make sure, are these valves actually open? Okay, if they're not open for some reason, even if it says beam on, then that's a clear problem, right? Because you're not going to be able to get a beam through the valves. Okay, so that's another thing you can check if you're not seeing anything, okay, is pull up the vacuum diagram and make sure these are actually open when you have beam on activated, okay? So we're good here. And let me go ahead here and I'm going to change this to 2 kilovolts. And I'm going to change this to 0.1 nanoamps. Okay, so let's start by addressing the SEM column first, okay? So we have this activated, we have beam on. So now if we unpause the quad, we should see something. Okay, and we do. So I'm gonna click F5. That's gonna make this full frame. Let me move a little bit because we're over kind of just a hole here. Okay, that's as far as magged out as I can get. Okay, so if you turn on or if you unpause the quad and you don't see anything and everything seems okay otherwise, then where I would start is actually going to the direct alignments, okay? So if you find your direct alignments module here, the thing you need to check most likely is this crossover, okay? So if we click on crossover, so if the spot is not centered, then you're probably not going to see anything in your image, okay, except noise. So just to show you this, right, if I move this way off, okay, see what happened, right? I mean, this is just completely black. Now, if I go to the histogram here, so, I'm adjusting my contrast and brightness so you can see, noise, right? But this is all it is. It's just noise, right? There's nothing here, okay? I'm changing the mag, nothing's happening, okay? And that's because, again, I have that crossover spot misaligned, okay? So that's the next thing to check, okay? Make sure this crossover spot is actually centered. So if we click on crossover, okay, and now because I fudged with the contrast and brightness, that spot looks brighter than it is. So you can click and drag on source tilt. Now another wrinkle with this, if you have a system with U mode, okay, which is monochromation for the SEM column, you have to perform the UC centering frequently, okay? So if you're going into crossover mode in U mode, so the way to check if you're in U mode here, if you go to, is it beam? Yes. So if you have UC auto checked, then if you have the appropriate beam conditions for UC mode or U mode, it's going to turn on UC mode. Okay, so basically UC mode will be applied anytime you're at 5 kilovolts or less and your current is 0.1 nanoamps or less. Okay, that will turn on U mode. So you can watch here. I'm just going to go up to 0.2. Okay, and you can see now, right? It's not, this UC centering is off, okay? And you can see here, right? If I go to beam, UC is on is also not selectable, okay? Because that's the cutoff, okay? Same thing applies here though, right? So you want to make sure you're centered. Now if you're off by, so even right here, you're probably going to see something, okay? Because we have enough of this centered, okay? But obviously you don't want this, right? I mean, you want this well centered when you're working, right? But even if this is, you can see just a little bit in the centered, we're probably still going to see something in the picture. Yeah, so we're still seeing, an image here, okay, very clearly. Now we're probably taking a hit in terms of how much current we're getting out, though. So we can actually see, let me switch back to full mode. Okay, and I'm going to move over to my Faraday cup here. Okay, there's my Faraday cup. So now if I mag all the way in on this, so the Faraday cup is completely in the view field. Okay, so you can see, yeah, so we're still reading basically the entire beam current we should. Okay, so yeah, as long as you have that spot, part of it in the center, you're still gonna get all of the current. But again, you don't want to do this, okay? You don't want that when you're actually, using your system, okay? You want this crossover spot centered, okay? Like this, okay? For for the alignment to work properly downstream, okay? But what I was getting at though, I'm gonna go back to 0.1, so I turn UC mode on, okay? Is that the UC centering has to be done frequently, okay? So if the UC centering is not done frequently, then when you go into crossover mode here, you may not even see a spot here, okay? Or the spot, like you can see, we have a spot that's basically, it doesn't have any like, what I've seen sometimes with this when the UC centering gets off by quite a bit is you sometimes see like a black area in the middle. You can see that this is a continuous bright spot, okay? So that means the UC centering is probably still, reasonable. But if it gets really, really far off, you may not even see anything here, or you may just see like a spot that looks kind of cut off, okay? So that's the importance of why you have to do the UC centering periodically, okay? So now you do have access to this manually, but this is tricky to do manually. So there's a way to do this automated, and that's really the best way to do it, okay? So if we turn off crossover here, so I know I've done this in a previous video, but I'm going to go ahead and just do it anyway. So you want to go to alignments. You don't have to be in service mode for this. Click on electron beam and click auto U mode source centering, okay? So now you do want to be over an area here that's basically uniform. So you notice I don't have like any big holes here in the center, or else I've seen that give a problem when it does this. Normally I'm doing this with 2 screens, so this is probably going to look a little bit different here with just 1 screen, but well, we'll see what it does. Okay, so there's the spot. Okay, so we're all done. Okay, so yeah, everything looks okay. Let me move out of the view of the Faraday cup, turn on crossover. Yeah, so I mean this is fine now. So yes, that's what you need to do with UC mode. So again, and that's, you know, if you go up past 0.1 nanoamps, UC mode is no longer activated anyway. So you know this is less affected there. Okay, but that's another wrinkle to consider. Another thing to consider with the SEM quad, right, is your apertures may just be kind of out of sorts, okay, and just not properly homed. So if you go to beam, there's an option here to home the SEM apertures. Okay, this is another thing you can do if you're not seeing anything. Is just you can tell it to run this. I mean, everything's looking okay, so I'm not gonna do that. Okay, but this is another thing you can do if you're not seeing the behavior that you're expecting to see. Okay, all right. So that is what to do with the SEM quad. So now what I'm going to do here before we talk about the FIB version is I'm going to get us much closer to eccentric height. Now I think, whoops, mean distance should be getting closer to 4. All right, so let me mag out here. I need some kind of reference point here. I can use this thingy. All right, so we're still a little short. Oh, that was off by quite a bit. Let's see here. Okay, all right, let's try it now. All right, so oops, all right, so this is checked. This should have been, did you notice how it was jumping when it tilted? Yeah, this shouldn't have been checked, so that's why that happened. Let me put this back here. There we go, so now it's not jumping. All right, so we're pretty close here. All right, so we're at mechanical eccentric, and we're at 52 degrees. So let me pause this. All right, so now for the fib column, you know, some similarities, right? So again, it turned off the beam. So I've seen it do this as kind of like a source saving mechanism. If you don't use it, it will sort of, it'll auto turn it off basically. Okay, so the emission's still on, so just click beam on. But yeah, it will do this if you go, you know, so much time without any activity, which I suppose is a good thing since you're trying to, you know, not waste your xenon. Okay, and so we've got a beam. Now your ion current here should be reading nominally what you have here. Okay. If this is not, if these current readings are not responsive, if they're just bottomed out at 0, then most likely these are not working properly, and you might need to do something like a full system reboot. Okay, which I covered in a different video. But since these are actually giving us readings, we know that's not an issue. So anyways, this is reading nominally 10 picoamps. So if we click on this, okay, yeah, so we're seeing something. Now with the FIB column, there is no source crossover, okay? So what you can check though, again, right, if you're not seeing anything, you can do the home FIB apertures as well. Okay, if there's nothing coming out, or if this current reading looks a little fishy to you, right? So you can again run home FIB apertures. Now another thing, and I should have touched on this with the SEM image, okay, is to make sure that you have the right detector activated. Okay, so if we unpause this, okay, go to your eyeball menu here. Okay, so if you have if this is on external, okay, you may not see anything here, but a gray thing, okay, or a gray picture, right? So you have to make sure this is actually set to the right detector, okay? Normally we use the ice detector here. If you have an ice detector, that's really optimized for the ion beam. You can use the ETD as well, but if you have an ice, that is preferred to do that instead, okay? But yes, you want to make sure that this detector is set correctly, okay? So if this is not set correctly, then that can be another reason why you are not seeing anything when you are expecting to see something. Of course, you can also do black and white cookie here. So that's auto contrast and brightness. So this is already optimized. So again, what it's doing here when it's doing black and white cookie is it's doing what's called a histogram stretch. So it's basically trying to stretch the histogram to fill the full dynamic range. So I think as we increase the time here, we're going to get better signal to noise. So we probably have a little bit of clipping here at the bottom. So if we do black and white cookie now, yeah, so it's not much different. I mean, so it is doing a good job with the stretch. This is probably a little too stretched here because we're probably getting a little clipping on the bottom. So what I'm going to do here, I'm going to decrease my contrast, and then I'm going to bump up my brightness so that I don't have these kind of all the way down. Okay. And this is also perfectly fine. It's fine to have a little bit of headroom at the top, and then I guess you wouldn't call this headroom at the bottom, but so you're not, bottoming out the signal or maxing out the signal. Okay. So, and yeah, another thing to check obviously is your detector contrast, detector brightness as well. We can do the same thing with the SEM image. So let me go ahead and pause this. Switch back to the SEM quad. And yeah, so again, if this is on external, you're probably not going to see anything. So make sure this is on what you're hoping to be. If you're in field free mode, you probably just want to use the ETD. You can use the through lens detector. Again, ETD is Everhart Thornley detector. You can use the through lens detector or the TLD when you're in field free mode, but this is really optimized for when you're in immersion mode. You cannot use the ETD in immersion mode. ETD is only in field free mode. Okay, but this is normally what we use as a default when we are doing SEM in field free mode, or what I like to call single UFO mode, right? Single UFO. If you go into immersion mode, then you're in dual UFO. And I believe when you go into immersion mode, you do not have an option for anything but the TLD. You may have an option to select external. I mean, we can actually, we can check it here. Why not? I'm going to tilt back to 0 degrees because it's easier to do SEM on a flat surface than a tilted one. So we'll actually check this to make sure. All right, so let's head into immersion. Now, in order to go into immersion, your mag has to be high enough to do this. So you can see if I mag, oh, it's still letting me go into immersion. Okay, oh yeah, so it's saying, okay, so it's automatically gonna increase the mag if you do this. I know on the other system, you have to be high enough mag before you get access to immersion mode. So so it doesn't really matter in this system. So all right, I'll leave it at 2000 here. Okay, and then we'll go into double UFO mode. Okay, so we're seeing something here. So let's do F9. Okay. And if we go to the eyeball, yeah, so it's only giving you an option for TLD and external. You do have the choice though in TLD to change the condition. Again, this is not really secondary. It's really secondary plus backscattered. But you know, if this is if you're doing backscattered only, your signal is going to be weaker than if you're doing secondary plus backscattered. So that's another thing to check, is to make sure that this is what you're expecting it to be on. Okay. Okay, so we got some lens align here, but that's, you know, neither here or there. We're just trying to go over, you know, finding the beam. I have seen it be an issue when you switch from single to dual UFO mode, that the crossover spot can sometimes move. Okay. It doesn't seem to be doing that here, but I would recommend, you see the dark spot in the middle. This is because we're over that patch of crud. So you can see if we move out of the way, yeah, that patch of crud is no longer there. Okay, so I would check this crossover spot again once you switch into immersion mode, okay, just to make sure. In principle, it shouldn't matter because that's an issue with the gun, not an issue down the column. So this shouldn't be affected by your choice of, you know, final lens here. But I have seen that empirically be not the case. Okay. All right. So we covered that. Let me go back to field free because I think there's one more thing I wanted to touch on here. Okay, so if you're using the ETD, you do have an option here to do backscattered only in the ETD, okay, as well as secondary plus backscattered. So, you know, you can, again, if this is looking weird to you, make sure that somehow this didn't accidentally get set to something else, okay? So this gets set to backscatter, like, I mean, we're still seeing something, everything else is good, but the signal is going to be a lot weaker now because we're only getting, you know, backscattered electrons, and the, you know, solid angle of collection of our ETD is not terribly high. So anyways, you know, just another thing to check. If you, this is on, you have a custom here for the grid voltage as well. So, you know, make sure this is where you're expecting it to be. Okay. So I think that covers pretty much all of the major reasons why. Okay, no, I lied. There's a couple other things to check. Okay. So you do have on here, you do have beam blanks, okay? So if you go up to scan, okay, you do have the option to actually blank the beam, okay? So it should say beam blanked up here, okay? But if you're not seeing anything, right? So it is still scanning. The image isn't paused right now, okay? But the beam is just blanked off. So like I'm changing my contrast and brightness, right? You can still see, you know, noise here in the picture, okay? But this is another thing. Make sure your beam blank somehow didn't get turned on by accident, okay? And you can do Control B or just go to scan and then uncheck it. I also have it here in the toolbar, okay? This is the link to the beam blank, okay? Same thing is also the case for the FIB quad, okay? So again, there's a beam blank there as well, okay? And again, just make sure that this is not expectedly on for some reason, okay? Now I wonder if we open up the vacuum here, okay, so it's not actually showing any blank in the vacuum diagram. So is it? Is it showing any blank here? No, it's not showing any kind of blank here. So, okay. Yeah, I know. I think with the same, there's a similar diagram with this for the STEMs, where it actually will show if the beam is blanked or not. It's not doing that here. This is just the vacuum component. So, anyways, just wanted to check with that. Okay, but yeah, there's another wrinkle for you. Okay, make sure that you don't have the beam blank on by accident. Okay, all right. So I think that pretty much covers the dual FIB SEM version of what to do if you can't find the beam. Okay, so hopefully that was useful and helpful for you. If you have any questions, please let me know, or maybe something that I may have missed. I think I was pretty thorough there. So, okay, thank you, everyone.